Yeah, let's do it. Hi, everyone. My name is Sky. I'm the Chief of Staff here at Statsig, and I've been working really closely with Joe on all of our AI efforts.
Hey, I'm Joe. I'm also an engineer here at Statsig. Mostly work on the enterprise engineering team, which helps supports our customers, but also been taking the last few months to sprint on AI stuff here.
All right. Yeah, we can get started here. Sorry, Morgan. I just wanted to make sure we had enough time for people to join. Joe, do you want to kick it over to the next slide?
Yeah.
Cool. So Statsig has recently begun to invest in some AI features as well as AI-focused solutions because we've seen this real influx of customers who are using us to test and launch AI-powered features. And what we've learned from those customers is that it's hard to launch AI features, but experimentation makes it easier for two primary reasons. One, experimentation allows you to understand the impact of your features on your user experience faster, particularly if you're a company that maybe isn't an AI native company, but has an existing user experience that you want to preserve. And so experimentation lets you see, okay, we launched this feature, it seems cool. Does it actually move user metrics in the way that we want it to? It's also really useful because gating every AI feature that you launch helps protect the user experience. So using things like progressive rollouts or targeted rollouts really helps you understand if the feature is moving metrics in the way that you want before you roll it out to every customer. And both of these things actually enable you to launch AI features faster and more confidently over time. So how do we help companies launch and measure the impact of AI-powered features? First, we enable safe rollouts of new features via feature gates, like I said, progressive rollouts and targeted rollouts. Second, we unlock online testing using real user data. So you can think about launching AI features the same way that you'd think about launching any other experiment, where you're basically shifting parameters in an experiment. In this case, it can literally be launching the feature itself versus not launching the feature. It could also be multiple models. It could be multiple model parameters, such as prompts or temperature, or hyperparameters or anything else you want to adjust. So we allow you to conduct online testing using real user data, and that includes automating experiment creation and assignment, logging all the key inputs and outputs, measuring impact based on your core user metrics. And then, as always, we have an amazing stats engine that translates all of those measurements into actionable insights. And all of this serves to increase experimentation velocity and empower teams to launch new features because everyone knows how to keep track of whether the features are working as intended, and they also know how to roll those features out safely over time. So that's kind of a brief introduction to how Statsig helps empower companies to build and launch AI features. Now I'll kick it over to Joe to actually run a demo of what this looks like in practice.
Thanks, Guy. Cool. I'll be running a demo on a sample project that we built out here called Statsig. So it's just a toy project here that we built out that answers questions that users might have about Statsig. So for example, here we can ask about how Statsig can help me with running an experiment. So as we wait for the response to generate, we're actually using the OpenAI APIs, the completion API, to actually create a response to generate a response to the query. So here you can see that OpenAI responded with Statsig can help you with running an experiment by providing you with the feature gating and experimentation platform. Pretty good. Cool. So in the OpenAI APIs, there's actually a lot of parameters that you can actually pass in to modify the output of the response that you get. So in this example, in the spec here, you can see that some parameters that you can pass in are prompt, max tokens, temperature, and a variety of other things that control the response that you get. So let's say you have a hypothesis that longer responses would be more useful to your users, and maybe that more random responses might be more fun for your users as well. So you would want to run an experiment on controlling these two parameters. So in order to do that, we can go into the Statsig console to actually set this experiment up. So let's go into that now. So in the Statsig console, I have a project set up for Statsig. And we can create an experiment on temperature and max tokens. I already have one created here, but I'll just go through the creation process again so we can see how exactly to set this up from start to end. So here we can create a new experiment called temp and max tokens. Put in a hypothesis that longer, more random responses are better for users. And we'll create the experiment. After creating the experiment, we'll be led into a setup page where we can add some metrics to test against, and then also set up groups and parameters. We'll set that up first. So as you can see in this group and parameters view, I'll just zoom in a little bit. You can see that for 100% of users, we'll be splitting them between a control and a test group here. We can add more groups if we want to test against more variations, but for now, we'll just stick to control and test. And we can add some parameters to actually test against. So in this case, we'll test against temperature, which is a number, and max tokens, which is also a number. So the defaults for the OpenAI API are 16 here and 1 for temperature. But for our control group and in the code, we've already specified temperature to be 0 and max tokens be 256. We'll increase the test group to have a max tokens of 512 for longer responses and a temperature of, let's say, 1 to have more variability in our current responses. Cool. So we can actually save this now and start going into code and seeing how we can actually use this in our project. So inside code here, I have the code for Statsig. Zoom in here to make it easier to see. And we can see that using this, this is a node project written with Next.js. And we're grabbing the experiment value from the Statsig React SDK. So we can grab the experiment, temp and max tokens experiment, and then pass them into the OpenAI completions API. So here we're grabbing the temperature parameter that we defined in the experiment, and also the max tokens parameter that we defined in the experiment, and then passing them into the completions API. So now when users come into the product, they'll be split into one of the controller test group and then grab a parameter from the group that they got assigned to. We can see this in action by testing it out using overrides. So here I'm setting our user ID to 123. So when I go back into the console, I can say that for user 123, give me the test group. Here I'll save, and then I'll go into the localhost app that we just tested out and then try out a response again. So how can Statsig help me with running and experiment? Great. So as this is generating response, I'll also run through how to actually log metrics. So we can see here that after the response completes, we'll log some core events that are related to the response of the API. So here we're logging response time, which will help track how long responses are taking based on the different variants of our experiment. The finish reason, which will help track how many errors or like the reason, like how many successes of responses we're getting. Then also completion tokens, which will be useful for tracking how expensive each experiment variant is. We can also track product metrics. So here we are logging responses from clicks. So if we go back into the app that we built, we have a "was this helpful" button that can track whether a user felt that the action was helpful or the response was helpful or not. And we'll track that by logging an event over to Statsig about whether it's helpful or not helpful. Cool. So we've gone and tested this out on the new response. We can see here that they're actually about the same length. So not too much difference in the length here, but we can go back into the console and look at the diagnostics for the stream here. And we can see that the last, let's go back here. Just going to refresh here. We can see like some results in the diagnostic stream that tell us that like for user 123, this was actually an older test, older log, but we'll be able to see like for user 123, they got put into the test group, and yeah. So from now, we can actually start running this experiment on the different groups and have them bucket into test and control. But before we do that, we can actually also add targeting. So this is the piece about how to actually roll out our new AI features safely to new users. So here in the groups and parameters tab, we also have the ability to specify who to actually roll this feature out to. So right now it's to all allocated users. But let's say we want to safely roll out to a country first. We can actually create a new targeting gate. We'll just name it max temp, and max tokens rollout. And this. And define rules for who to actually roll the feature out to. So in this case, if we wanted to only roll out to users in the US first, we could create a rule that limits this feature to just users in the US. We could create a criteria that passes users in the country of the US and save this. So going back to the experiment, low will be to only allow users, sorry, wrong experiment. Will only to be allow users who are in the US to be put into control and test. Great. So now after saving this experiment, we can start it and we can start controlling the experience that users get based on the group that they get assigned to. After a while, we'll start receiving pulse results, which will actually tell you the lift between the test and control group. I was running another experiment that was very similar on a small set of users in Statsig, and we can start seeing the delta lift between the two experiment groups slowly here. We can slowly start to see that the number of tokens that we use in the test group is skewing towards more positive. For a better example of like what results might look like, I'll go back to the slides here and show a sample experiment result of maybe testing against GPT-4 model versus like a GPT-3 model. We can see that in our sample test here, the thumbs up has gone up, the thumbs down has gone down, which means that the responses are better. But then we've also noticed that latency has gone up with the new model that is a lot slower. Cool. One more feature that I wanted to show is our layers feature, which is a feature that will be very useful for increasing experiment velocity. So our layers feature will allow you to run multiple mutually exclusive experiments at the same time on all your users. So within a layer, you'll be able to find many experiments and will actually control which experiment a user gets put into within the layer. Additionally, parameters will actually get pulled from the experiment into the layer, so the parameters live at the layer level and be reused in all the experiments that you define within it. So in practice, what you can do with layers is create multiple, define your parameters within your layer, and then define multiple experiments within your layer. And then in code, you could, instead of defining the experiment that you want to pull, you would define the layer that you want to pull. So it would look like use layer. In this case, I have it defined as open AI model params. And we can actually grab the parameters from the layer. So now, when you're actually trying to run many different experiments on the same model parameters, we wouldn't have to make a code change, as all the experiment parameters will be defined in the layer level. In the flip side, if you use experiment directly, you would actually have to create a new experiment and then change your code to update it to the new experiment, slowing down your experiment velocity. So this would be very useful for reusing the parameters across multiple experiments and allowing you to run many experiments on the same model parameters at the same time. Cool. That's all I had to show for the demo. I'll kick it back to Sky to wrap it to close on our presentation here.
Sweet. Yeah, so as we've started to build AI features and as we've observed what our customers are doing, we have a few high-level takeaways on how to get the most out of experimentation when building with AI. The first of these is to launch new AI-powered features via a progressive rollout. So essentially launching features behind a gate and then upping the percentage of users that are exposed to that feature over time. Alternatively, if you're a large company that has users in many geographies or on many devices or applications, launching in one application or one geography and then seeing those results is another good approach as an alternative to progressive rollouts. The second is to start logging core AI metrics in addition to existing product metrics. One of the key things that we've seen customers using us to do is measure trade-offs between cost, latency, and performance. And so if you're a Statsig customer and you're launching AI features, it's very helpful to log all these metrics, all these model inputs and outputs immediately, so that you have that data over time to see the results of, for example, rolling out new models or trying different versions of models, especially as the number of models that are possible to use proliferate. And then finally, beginning to run online experiments with different versions of models and model parameters. So again, as more models come online and as providers like OpenAI release different models, and the ability to fine-tune models is more and more prevalent, it's very helpful to get comfortable with, for example, swapping out GPT 3.5 and GPT 4 in a given application for certain users, or testing different prompts online versus just running offline tests. Often it's very hard to tell whether the changes that you've made to a specific prompt or model parameter are working as intended. And so the best way to test that is to run online experiments, because you actually get to see results on real user data. And then I think we'll close with just some final thoughts on like where Statsig is going and where the industry is going. So where are we heading? From an industry perspective, we think that there will be a lot of AI-powered features in most applications. And so getting comfortable with building applications that are built around AI features is incredibly important. There will be dozens of different performant models that can be used for a given application. Some of these will be proprietary LLMs, like the type of things that OpenAI is putting out. Some of them will be open source models that you'll fine-tune for a given use case that's very specific to your application. And there'll be a range in between. And so the ability to swap out different models and actually test using different models and product is going to be a key competitive advantage for any company that's building with AI. And then finally, we'll see widespread use of open source models that are optimized for a given use case. And I think what we're actually going to see is in a given application, there may be 5 or 6 models that are used in conjunction, some of which are done via rule-based targeting in the same flow, and some of which are used for different purposes, on different surfaces. So Statsig's responding to this by basically enabling builders to more easily design for this future with some partnerships as well as some product features. So one, we're exploring partnerships with leading ecosystem providers, namely LangChain. Anyone who's used LangChain knows that they're kind of the gold standard for abstracting away from a given model and letting you plug and play with different models and additional context within a given application. So we're really excited about that. And then we're also evaluating features to streamline logging of core model inputs and outputs, things such as prompt, choice, cost, latency, et cetera, to make it that much easier to run experiments. And then we're also working on some templates to really showcase how easy it is to experiment with this using Statsig. So yeah, that's where we think the industry is going and how we're going to help you all get there. I think now we're ready for Q&A.
Yeah, thanks, guys. Julian asked a question that I wanted to answer first. Statsig is open source, or can I get an example repo?
It's not currently open source, but it can definitely help do that. Help open source this after the talk.
Yeah, we can follow up with you if we want to make sure that we're connecting and getting all that taken care of. All right, next question. Would love to learn best practices for auto tune feature. We have a test plan to try it out in the next month or so.
Yeah, I can take that. So some best practices with auto tune is auto tune works best when it's so auto tune is our multi-bandit solution. So it allows users to define multiple different variants and for us to and a core metric to optimize, and then for our system to decide which variant of it actually performs best when it comes to that core metric. So some useful things to know about AutoTune are that it works best with many different variants, as it will be able to decide which variants are actually going to maximize the metric that you're trying to optimize against. And also it's really good for being able to automate the number of experiments that you run, as we'll be able to, you'll be able to skip like doing experiment review, as you'll be able to optimize as the decision criteria for the rollouts will be defined at the start.
Awesome, thanks, Joe. Okay, another question here. How durable are insights from experimentation on probabilistic Gen AI systems versus deterministic systems?
So with probabilistic, so with the new generative AI systems, my understanding of them is that the models are still pre-trained. So they still should be relatively durable for in terms of the results that you get. We always recommend for like rerunning experiments very often, and to make sure that your results are as you expect, even throughout your product life cycle. So definitely recommend that. And we also have our holdouts feature, which will allow you to basically see how over a long term how users are still the users in your experiment groups are still behaving across the long term of the rollout.
Yeah, I think what's interesting about this question is the subtext is given that these results may not be durable, why do I experiment at all? But I almost feel the opposite. It's given the probabilistic nature of these models, you have to experiment. Otherwise, you won't be able to understand the persistent impact of changes that you're making on user metrics. So I think it's a case to experiment a lot more and be much more proactive in experimenting as you release and change features versus basically, giving up on experimentation because the results may change.
Awesome. Okay, we got time for a couple more questions here. Are experiments human-driven or hyperparameter tuning? Sorry.
So I think this question is asking about whether or not the experiments that you run are going to be based on humans deciding the inputs to put in, or are these mostly just optimizing the parameters that are passed into the OpenAI or passed into your OpenAI models. I think that generally there's many different things that you can experiment on. So for example, the field of prompt engineering will be more human-driven experiments where maybe you're trying to test out different prompts that are more rich, and you're not really you'll be testing out different ways to prompt the model with different sentence structures and different different ways to structure the output. So that will be a lot more human-driven. And while you can also do hyperparameter tuning to optimize which model parameters you're passing in. So definitely like a mix of both here.
Got it. Thanks for the correct pronunciation on that, by the way. What is the best way to analyze adoption and conversion in the same experiment?
Yeah, so I think that this question is asking about how to best analyze like user metrics, so adoption and conversion. So this would be like tracking against like many different like event types. So for adoption, you might be looking at maybe like new users coming in. So you could log like events based on new users that you see. So like maybe like signups, and then also conversion. This would maybe be like rather than like signups, like maybe like purchase events would be something that you consider a conversion. So this would mostly be around making sure that you log the metrics that are important for what you consider in your product to be adoption and conversion, and logging both. And in our experiment results, we should be able to show both for you to track.
Got it. Okay, we just got another question submitted. Besides doing it manually, is it possible to set up a feedback loop where the experiment results are used to optimize the model params in a continuous manner?
Yeah, I think that's basically returning or referring to like our auto tune solution, which is essentially our version of a multi-arm bandit test, which will auto optimize. You can use auto tune to run in a variety of use cases. It tends to work a little bit better if it's like a continuous value, but for example, we use it on our website to optimize like different versions of the text on a CTA button. And so an example of how you could do this for something like prompt is to say, I have these 10 prompts that I think would work well. You set that up in auto tune, so multi-arm bandit, you set those as the 10 options, and you let that auto optimize the prompt for a given metric. The only downside of that is, given the way that that works, you're basically optimizing for a single user metric, which I think often fails to capture some of the trade-offs that happen with different prompts, where maybe a prompt is better at driving engagement, but it also drives up cost, or it also increases latency. And so there's just some trade-offs there that we feel are best addressed in an experiment format, where you can see a whole swath of results as opposed to overfitting for a single user metric or a single variable. Hopefully that answers the question.
Thanks, Guy. All right, we got another question about Statsig. Is it deployed somewhere, and can we try, or is it just a local demo app? No.
It is currently deployed, actually. I'll just show some other features that we have that might be more fun to play with. But if you do want to play with Statsig, you can actually go to statsig.vercel.app here to try it out. But we do also have a docs bot that we can play with. If you go into our docs page /search, so if you go to docs/search and then input the URL param chat equals true, you'll be able to actually talk to a bot here. Any like question that you might want to ask it? So for example, we can ask like questions like about here, like what are auto tune best practices? We're using GPT-4 here, so it'll be a little slow, but yeah, you can test it out in our live production docs page here and ask questions and get some responses back.
And Joe, we can add some of those links into the follow-up emails as well, correct?
Yeah, for sure.
Cool.
Just some context on this one we built using there was a common like LangChain to chat with your docs public repo out there that we use to build this and have been iterating with. So if you're interested in building something like this, we can share that as well.
Okay, I think we've got time for just one more question. We're just about at the 30-minute mark. What's the long-term plan to integrate with popular AI model and services?
Yeah, I think I can take this one. Oh, nice. We got a response. Let's see, was it a good one? I don't know, Joe, what do you think?
Yeah, I think it's pulling some best practices that Tim outlined in his AutoTune best practices blog, which will also be linking inside the email reach out. But yeah, looks like the response is pretty good here.
Cool. Yeah, what's the long-term roadmap to integrate? So like I said, we're exploring partnerships specifically with LangChain. I think we're also going to build, so there's kind of like 2 or 3 major categories that I'd say that our eventual feature rollouts will fall into. One is quality of life things to make it easier to build and build and measure the performance of AI apps with Statsig. And so a lot of that will be like SDK wrappers or packages that you can install that will effectively auto log or auto allocate users to a given experiment to help you roll out experiments more quickly and then measure the results. There's also some stuff that we'll do on the console side that actually provides like pre-populated templates. So that's kind of the second category. And there's this third area of specific features that specific incremental features that we're exploring to make AI experimentation easier kind of on the back end. An example of this is recognizing different AI like sessions based off of topic type, based on the event you log, to kind of change the experimental unit to be whatever you want it to be, whatever you determine is like the appropriate session for testing. So an example of this is if I have a docs app, an AI session could look like every time you have a call. But if you're doing something like planning a trip to Paris, a session is actually, find me dates that would work around holidays, buy me a plane ticket to Paris, recommend restaurants, give me a walking tour guide of Paris. And that's, that's part of a whole session, but those look like individual calls. And then even in that same, user session, the user might switch context and say, they actually, I don't know, find me a restaurant tonight to eat at. And those are kind of 2 separate sessions. So we're exploring things like that, where it's like, oh, you could actually use that session as an experimental unit. And then that next session, when you switch context, is a separate experimental unit. So what we do is, recognize what those sessions are and allow you to like configure those. Anyway, probably too deep, but we're exploring things like that are kind of back-end features to make this sort of experimentation easier.
That's great. Thanks, Sky. Okay, that's all the time we have today. There was a lot of questions that got submitted during registration that we weren't able to get to today. So we're absolutely going to follow up with you individually to make sure that we can connect you with the right team member. If you have any other questions though, please join our Slack community. I threw the link in the chat and you can answer any questions there. You can talk to our team in real time. Thanks for joining us, Joe and Sky. Thank you so much for your time to make this happen. And we hope you guys join us again soon. Have a good one.
Thanks, everyone.